Hello student, my name is Ashok Kumar Lamba. Now we will discuss the topic logic gate and their corresponding truth table. Now, what is logic gate? Logic gates are the basic building block of any digital system. It is an electronic circuit having one or more than one input and one output. As you can see in the diagram, there are multiple inputs and only one output. The relationship between input and output is basically depends on certain logic. Which gate we are using, corresponding to that we will get the output. Next is type of gates. There are many type of gate. Basic gate, derived, universal. Basic gate are further and, not, or. These are basic gate, XOR, NOR. These are derived gates, and universal gate, NAND and NOR. NAND and NOR are universal gate because all the other gate can be derived from only using NAND gate, and all the other gate did derive from only using NOR gate. Next is uh, symbol corresponding to each gates. AND gate is represented using this symbol. The following, all these gates are representing using the following symbols. They are normally the symbols corresponding to each gate. Okay. Now we will discuss the truth table of each gate individually. First, NAND gate, AND gate. Okay, the symbol represented by and we use dot operator to show the output of AND gate. As you can see, Q is equal to A dot B. Okay, there are two inputs A and B and four different combination of inputs 0 0 0 1 1 0 and 1 1. And what AND gate implies is that if both or all the inputs are 1, then only the output is 1, otherwise output is 0. So in the first three cases the output is 0 because all the input are not 1, and in fourth case 1 1, where all the inputs are 1, then the output is equal to 1. uh, Next is OR gate. In OR gate also there are four possible combination of inputs because there are two input variable A and B. Then four combination of input are 0 0 0 1 1 0 and 1 1. But AND gate states that if at least one input is 1, then output will be 1, otherwise output will be 0. And you represent AND gate using plus symbol. As you can see, Q is equal to A plus B, and the output of Q or this circuit is where you have 0 0 input as input, then the output is 0. Otherwise, in all the other three cases, there is at least one input as 1, then you have output as 1. Okay. In last three cases, the output will be 1 1 1. Now NOT gate. NOT gate means the complement of what we are providing as input. NOT gate, what we NOT gate do is complement the input. Okay, it is represented by bar. As you can see, Q is equal to A bar. Okay, this is the output. uh, when you apply the input A as 0, then output you will get the output as 1. When you are giving input A as 1, then you will get the output as 0. It simply complement the input. Next is NAND gate. What NAND gate does is it is the combination of AND gate and NOT gate. So whatever the output we get at the AND gate, it complements NOT gate complement that input output. Okay, so it is represented using A dot B ka bar, whole bar, because NOT gate puts the bar over A dot B. Okay, the as the AND gate statement says, all the output will be 1 where all the inputs are 1. But in NAND gate, output will be 0 where all the inputs are 1. In all the other cases, output will be 1. Okay, it is simply the reverse or complement of AND gate. Okay, so at 0 0 we will receive output as 1. At 0 1 also 1. 1 0 we will get the output 1. At 1 1 in AND case we will get 1 only here, but in NAND case we will get 0 only here. Okay, then NOR gate. NOR gate is simply the complement of OR gate. It is the combination of OR gate plus NOT gate. So the output Q is represented using A plus B whole bar. Okay, and the output is also state that the NOR gate state that output is 0 if at least one input is 1. If there is any input which is 1, then their output will be 0. Okay, opposite to the OR gate or complement to the OR gate. So we will receive at 0 0 we will receive output as 1. At 0 1 we will receive output as 0. At 1 0 we will receive output as 0. At 1 1 we will receive output as 0. Okay, as you see, in the first case only we will get output as 1 because there is no input which is 1. Next is XOR gate. As you can see, the symbol of XOR gate is equivalent to uh, OR gate, and it is represented using the plus symbol inside a circle. Okay, and it states that output is 1 only if one input is 1. If we have two input A and B, then output will be 1 only if one of these two input is 1. If both the input are 1, then output will be 0. If both the input are 0, then also the output will be 0. Okay, in case as you see in the table, at input 0 0 output will be 0, and also at input 1 1 output will be 0. In all the other cases like 0 1 and 1 0, the output will be 1. Okay, except that output will be 0. Okay, if we have more than uh, two variable here, then the statement changes. As it says the output is 1, then it says the output is 1 if only odd number of inputs are 1, then only the output is 1. Okay, otherwise the output will be 0. Okay, now in case of XNOR gate, which is the complement of XOR gate, it is represented using plus symbol inside a circle and bar over it because it is the complement, and it can also be represented using dot symbol inside a circle. Okay, as you can see, Q is equal to A XOR B ka bar, and below you have Q is equal to A XNOR B. Okay, it can be represented using the both symbols. Okay, then we have for combination of input 0 0 1 0 1 1 and 0 1. Okay, now what the XNOR gate says is output is 1 if none or both the input are 1 in case of two inputs, but in case of more than two input, you can the XNOR gate states that the output is 1 if none or even number of inputs are 1, then only the output is 1, otherwise output will be 0. Okay, here we have 0 0, then output will be 1 because there is no input as 1. so output will be 1. And at the end, where 1 1 is number of 1 are even. Okay, the both the inputs are 1, then the number of 1 are even. Okay, then only the output is 1. In all the other cases, on the two cases which are the center two cases, 0 1 and 1 0, the output is 0. Okay, thank you so much.